Hello and welcome in our YouTube channel Metallurgical Facts. We are doing Vizag previous year paper of junior trainee, and this is part 7 of this video series. Before this we have already given 6 part of that video series, and all those part contains up to 55 questions. If you did not watch those videos, go through our playlist junior trainee previous year papers and watch those videos. In this video we will try to solve the question from 56. Okay, so the first question is bauxite, an ore of aluminum, is a mixture of. Okay, so this is bauxite is an ore of aluminum by which we extract the aluminum through Bayer's process and Hall-Héroult process. Okay, so option is gibbsite and dolomite. Okay, so this dolomite is basically magnesium carbonate and calcium carbonate mixture. Okay, so this is MgCO3 into CaCO3, and this gibbsite is basically Al2O3 into 3H2O. Okay, and this is also known as bauxite. And this the B option is gibbsite and diaspore. Diaspore is basically Al2O3. Only water content is different from the gibbsite. Okay, and C option is diaspore and dolomite. So this is not correct answer because this MgCO3 and CaCO3 mixture is dolomite. So A option is also not correct. And D option you can see that this dolomite is here also. So this is also not correct. So you can say that bauxite and ore of aluminum is a mixture of gibbsite and diaspore. Okay, so B part is correct answer for this question. So the next question is initial sound pressure. Okay, so initial sound pressure employed in ultrasonic testing is. Okay, so first of all you should know what is this initial sound pressure. Initial sound pressure is basically signal amplitude in ultrasonic testing. Okay, so A option is directly proportional to the linear coefficient of attenuation. Okay, so this linear coefficient of attenuation is basically the common effect of combined effect of scattering and absorption. Okay, so this is the this combined effect of scattering and absorption is known as attenuation. Okay, and the B option is inversely proportional to the linear coefficient of attenuation. C option is directly proportional to the exponential of linear coefficient of attenuation, and D option is inversely proportional to the exponential of linear coefficient of attenuation. Okay, so the formula for signal amplitude, you can say the formula you should, for relation you must know about the formula. Okay, so A is equals to A naught exponential of minus alpha z. Okay, so this is the formula. Here A naught is initial, you can say initial un unattenuation, okay, unattenuated amplitude. Okay, and alpha is basically attenuation coefficient. Okay, so from here you can observe that what is the relation between this A and this alpha. Okay, so Z is traveled distance. Okay, so this is the formula which you can relate into the ultrasonic testing. Okay, so this A is basically sound pressure and also known as signal amplitude, and this A naught is initial at unattenuated amplitude. Okay, and this alpha is attenuation coefficient, that is also known as linear coefficient of attenuation. Okay, so from here you can observe that initial sound pressure is basically proportional to exponential of linear coefficient of attenuation. Okay, so this C part is correct answer for this question. So the next question is open hearth furnace is. Okay, so they are asking about the this furnace and which is based on. Okay, so this coke based furnace, coal plus coke based furnace, coal based furnace, and liquid plus gaseous fuel based furnace. Okay, so this open hearth furnace is basically, you have heard that you must have heard that this open hearth furnace is mostly used in steel making, and in some steel plant like Sale Vilai, also they have twin hearth furnace. Okay, so those furnaces are basically fired by oil or gaseous fuel. Okay, so D option is correct for this question. Liquid and gaseous fuel based furnace is open hearth furnace. Okay, so D is correct. So the next question is during electron beam welding of 1 mm thick steel plate. Okay, 1000 watt power is utilized at welding speed 25 mm per second. The heat input required for the welding of 1 mm thickness steel plate is. Okay, so for this type of question I have already given one video on welding numericals based on welding processes. Okay, so you can watch those videos from playlist. Okay, so heat input, how we can calculate heat input is basically Vi by V. Okay, so this V is voltage in volt, and this I is current in ampere. Okay, and this V, small v, is basically speed of that arc. Okay, so this is electron beam welding. Okay, so this Vi is what? This Vi is basically power, because P is equals to Vi. Okay, so this power by speed, if we will do, then we will get heat input. Okay, so here they have given power value, that power value is 1000, and velocity is 25 mm per second. Okay, and this 1000 is in watt. Okay, so watt is basically joule per second. Okay, and this is in mm per second, so this will get cancelled, and you will get your answer in 40 joule per mm. Okay, so the 40 joule per mm is correct answer for this question. So D is correct. So by balancing your unit, you may find the values, you may find the answer also. Okay, so for more videos related to the numericals based on welding process, you can watch that video. You can press the I button and you will get the link of that video. Okay, so the next question is, during the refining of nickel by carbonyl process, nickel decomposes into. Okay, so the option is pure nickel and carbon monoxide and oxygen. B is pure nickel and carbon dioxide. C is pure nickel and carbon monoxide. D is pure nickel and oxygen. Okay, so this carbonyl process is basically known as Mond's process. Most commonly, we say that this is Mond's process. Mond's process is also known as carbonyl process. Okay, in this process, what happens? First, this nickel will react with this carbon monoxide. This is impure. This is used for refining purpose. Okay, so this Ni will react with this CO, and this will make NiCO4 compound. Okay, and after that, what happens? This NiCO4 decomposes. This NiCO4 decomposes into pure nickel and and CO. So this is gas. Okay, so what happens? First, this impure nickel reacts with this carbon monoxide, and this makes NiCO4. And after that, what happens? This NiCO4 decomposes into this pure nickel. This is pure nickel, and this carbon monoxide gas. This is impure nickel. Okay, so this is all Mond's process, or you can say carbonyl process. Okay, so. For this question, correct answer is pure nickel. This, you can say that pure nickel is produced and carbon monoxide. Okay, so this C option is correct for this question, pure nickel and carbon monoxide. So the next question is, furnaces requires liquid metal, okay, to start the furnace. So they are asking about among of these furnaces, which furnace required liquid metal as a raw material to start the furnace. Okay, so the first option is indirect arc electric furnace, core type induction furnace, direct arc electric furnace, and coreless type induction furnace. Okay, so among these options, B, this is core type of induction furnace. Core type of induction furnace basically requires the liquid metal. Okay, so liquid metal to start the furnace. Okay, so this is fixed for core type of induction furnace. So B option is correct for this question. So the next question is arc blow during shielded metal arc welding. This is also known as SMAW. Okay, so sometimes they may ask in abbreviated form. So SMAW welding is controlled by. Okay, so in this SMAW type of welding, you can control this arc by controlling or by changing the alternative current. Okay, so the D option is correct for this question. By changing to the alternating current, arc blow during shielded metal arc welding is controlled. Okay, so D is correct. So the next question is, which among the following is not a non-renewable, that is fossil fuels? Okay, so the option is wood, with bituminous coal, anthracite, and lignite. Okay, so here I will classify about the non-renewable fuels. Okay, this is also known as fossil fuels. Okay, so non-renewable fuels are basically coal, crude oil, okay, natural gas, these all are non-renewable, okay, and also peat, lignite, bituminous, bituminous coal, these all are non-renewable fuels, okay, bituminous coal and anthracite also, anthracite, so these all are non-renewable. And what about the renewable fuels? So renewable fuels are basically hydrogen fuel, okay, biomass and wood, okay, so these are renewable fuels. So in this question they are asking which among the following is not renewable fuels, fossil fuels, okay, so you can observe from this list I have listed this wood as renewable fuels, this is not non-renewable, this is not fossil fuels, so a option is correct for this question, and these all are non-renewable, that is fossil fuels, only wood is not non-renewable fuels, okay, so a is correct, and you may remember these things, these examples for future exams, okay. So the next question is the defect which occurs when two streams of molten metal physically meet but do not fuse together is called, okay, so they are asking about we have two streams of molten metal and which physically meets but do not fuse together, okay, so if that will not fuse together, that will produce the cold shut, and that is known as that forms basically the discontinuity in the casting, okay, so this happens while cooling of the casting sometimes, okay, so D option is correct for this question. This cold set is basically happens when two streams of molten metal physically meet but do not fuse together, okay, and what is misran is basically when metal is unable to fill the mold cavity completely and then leave the unfilled cavity, that is known as misran, okay, and hot air is basically hot cracking. So the next question is which of the following are correct for dislocations? Berger vector is, okay. So this is the relation between Berger vector and edge dislocation and screw dislocation. Okay. So you must know about this relation about how Berger vector related with edge dislocation and screw dislocation case. Okay. So for this question we have to read options. So perpendicular to the edge dislocation. So Berger vector is perpendicular to the edge dislocation. So first statement is correct, okay. Parallel to the edge dislocation, this is not correct because already we did perpendicular to the edge dislocation, okay. So this Berger vector is perpendicular to the edge dislocation. The third statement is perpendicular to the screw dislocation, this is also not correct because this is perpendicular to the edge dislocation, okay. So this third statement is also not correct, and fourth statement is parallel to the screw dislocation, okay. So this is parallel to the this Berger vector is parallel to the screw dislocation, so this is screw dislocation line, so this statement is also correct. So first and fourth statement is correct for this question. So first and fourth, this is wrong, this is wrong, this is wrong, B part is correct for this question. So this was the simple question which relates the Berger vector with the dislocation line in different type of dislocations, okay. So thank you guys for your attention. Hope you have learned something new in this video. We will try to add more few more parts of this 2019 previous year papers as soon as possible, and we will also add the 2018 papers in this video series. Subscribe our channel and press bell icon to get notifications. Thank you.